Region planning influences the regional economic growth and development. Currently, regional policy-making decisions are based on past trends and ideologies. These decisions can be unsustainable as the landscape, infrastructures, and geographic proximities of each region differs. This problem arises as researchers have not been able to utilize all the data around and have solely based their decision on a limited set of data. Hence, our client, the Urban Dynamics Lab, have the proposed solution of developing an open source community platform to provide accessibility, modeling, and analytics of common geographical data. Open source data, such as transport data, provided by the Transport for London or TfL, and a number of research strands funded by the government will be processed and imported to its servers. Our team is responsible for the data pre-processing aspect. Our key requirements were to select one non-CCAN harvestable dataset and develop a data pipeline to perform a series of actions including retrieving, processing, and loading that data to our client's servers. We were required to schedule an automatic activation of the pipeline. Part of our task also included creating a specific and a generic matching algorithm to commonalize data, making them compatible and displayable. We were also required to visualize these clean data on OpenStreetMap. The main programming languages we used were Python for the data pipeline and JavaScript for data visualization. Python modules and libraries we used, for example, PyCharm was used to build our project, and CSV was used to parse and read CSV files. We also used APIs including the OpenStreet App Nomitium API and TfL Unified API for data matching. We created a scheduler using Uzi. We were also familiarized with Postgres and CCAN and HDFS Hadoop as they were used as our client servers. OpenStreetMap tiles the renderer. The open layer was chosen as a means of visualization. Our project contains an ETL, extract, transform, load data pipeline in Python, which retrieves CSV data from the TfL open source data. It then transforms it by auditing and cleaning it. In order to perform matching of the data, we send requests to the TfL Unified API to get the attributes of longitude and latitude, and to the OpenStreetMap Nomitium API for the node ID, which is the identity of each point on the map. We then audit the data again to make sure there wasn't any blank or invalid data. The data will then be outputted and pushed to our client's Hadoop server, or be matched and output as an OSM XML file, which will be stored to Postgres on our client's CCAN server. A scheduler is implemented using Uzi to activate the pipeline automatically and at a set time interval. We also created additional features, for example, an object pool to store and retrieve cached API responses from our API calls. In the case where API calls are unsuccessful, we will use the cached data. Another example would be the use of a template method pattern to reduce duplication in codes and to improve maintainability. Since each CSV file is different, if we were to generalize the pipeline for other CSV files, we would have to take into account of the different methods of grouping and organizing data. We have defined certain methods in a superclass, which are to be overridden in the subclass, and each different grouping method is described in a specific subclass. Our transformed data can be separately overlaid on OpenStreetMap with the use of a JavaScript renderer, the OpenLayer. We also developed analytical features such as clustering map and data points, which varied in size based on its occurrences in the dataset. Achievements. We were able to fulfill our clients' requirements, both functionally and non functionally. We have 1. Developed a data pipeline to process a non-CCAN harvestable data set such that it could be stored to their CCAN and HDFS server. Developed a scheduler to promote automatic activation of the pipeline. Developed a general matching algorithm such that all data sets could be related and overlaid. And lastly, overlaid the data on OpenStreetMap and additionally displayed analytical features.